Some of the brothers. They came with their argument.
Yeah.
Then we still got.
Yeah. Okay.
Oh, good, yeah.
Okay, turn to page 19. We're just going to continue working through this packet. And we're going to try to work through as much of the packet as possible. I will check the rest of these pages after break, but not the Monday when we get back. It'll be the Tuesday after we get back. So, but I think we can get through most, if not all of it today, and whatever we don't finish, we can pick it up on Monday. But we can also start looking at our second set of packets, which are review FRQs like Riemann sums and differential equations. I will say also that the packet, sorry, is a little bit out of order. I didn't realize that the pages were out of order. So I think page 20 through 24 is at the back of the packet, and the key is in front of it. So, but just slightly out of order. But let's look at let's go through page 19 first. Okay, so I'll read the problem and then point out what your first steps are, and then you guys can try it. Okay, so f and f prime are differentiable functions. Values of f and f prime are given as select values. It says g of x is f of x quantity squared. Find the instantaneous rate of change of g at x equals 9. So essentially, we're just finding the slope. So if I want to find the slope of g, I have to find the derivative. To find the derivative, what do we have to go through here? Chain rule. Okay, so go ahead and try, apply chain rule. All right, so go ahead and try that, and then we can go through it, but you guys can also check your progress. He is on page 21, which is a few pages later. Any questions with part A? Okay, next part. K is defined as f of 3 of x times x squared plus 1. Find the slope of the line tangent. So same process, or same idea. We just want to find the slope at a point. But if we want to find k prime of 3, what's involved here? Product, yeah. And there's a little bit of what here? Chain rule, yeah. So again, outside times inside derivative. So give that a try. Okay, next part, part D, evaluate the theft integral of f double prime of 3x. We know the integral process is going to make that f double prime rise up to f prime, but there's that 3x that's sitting here, so we do have to go through a little bit of use substitution. There's a 1/3 that's going to come out of that coefficient through use substitution. And now we can just go through our antiderivative. We know f double prime will rise up to f prime. So we're done with our calculus. We've taken care of the antiderivative. And now we just have to involve the bounds. But before we involve the bounds, you either have to convert the 0 and 3 in terms of u, or just bring everything back in terms of x and then use the 0 and 3 that right now is in terms of x. Okay, any questions here? Next page. All right, next part. Let n equal the integral from 0 to x squared of f prime. Evaluate n of 3. So n of 3, we can just go through first theorem, and then to find n prime, we can go through second theorem because we can take the derivative of the integral. Let's do n of 3 first. We just follow what the rule says. So we don't have to find the area under the f prime because we don't. I guess we could go through Riemann sums, but we can just do antiderivative, make f prime rise up to f, and we have order pairs at the f level, and so that can allow us to rely on the table and get the exact value. So we know f prime becomes f of x, then we can just plug in our upper and lower bounds. So f of 9 minus f of 0. Right, and we're just applying first theorem here. First theorem just says, if I take the integral from a to b of lowercase f, that becomes uppercase f of b minus uppercase f of a. So that uppercase just indicates whatever that antiderivative process is. In this case, for us, it's f prime rising up to f of x. We use our table of values to find those order pairs. Okay, before we find n prime of 3, let's build n prime of x first. So if you remember second theorem of this, if I'm pairing derivative integral process next to each other, their two cancel each other out, plug the upper bound into the function, then multiply by upper bound's derivative, right? So that's the process we're going to go through here. So if I want to find n prime, then it's just the derivative of the integral from 0 to x squared of f prime. So if we just want to work through second theorem, we know derivative integral process cancel each other out. This f prime is not going to change much. We just have to plug the upper bound into the given integrand and then multiply by the upper bound's derivative. So x squared becomes 2x. Okay, so now we can evaluate n prime of 3. All right, go ahead and try the last two. The last two are just applications of chain rule as well. Outside times inside's derivative. Oh, really, this just really just u prime over u. So Okay, pages are out of order. We can go to page 22. So so we have a derivative of function shown. F of 10 is equal to 5. Find f of 4, f prime of 7, and f double prime of 7. So this setup is a little bit different than the first page that we did. Like the first problem was more like this, where they give you a very specific definition, and then and you know you're involving the area under the graph, but you're told very specifically how to build that function. Here, they don't tell you a formula to plug in, but they do give you a starting point. So they give you a starting point, then you're going to use a different formula. You're going to use that final equals initial plus displacement. So if they give you a definition, a formula, then you use it. But if they don't give it to you, then you have to understand, okay, I have my starting point. I can do displacements involving area under the graph, and then the two of them added together will give me where I'm going to end up at that location. So if I want to find f of 4, because this is the f prime graph, f of 4 would be my starting point. It's not necessarily going to be 0. It's just going to be whatever they give you. So I'm starting at my anchor point is f of 10. And I have to bridge the gap between 4 and 10. But make sure that you know where you start and where you end. Sometimes they may be out of order. So because we're starting at 10 and we're going to 4, we have to follow that what the definition says. Okay? Our initial starting point is 10, and we're trying to backtrack to 4. So we're going to say from 10 to 4 of f prime. And because this is out of order, now I can flip it and involve the negative sign so that I can read from left to right. Okay, so we're going to have to involve all the areas region here. And sometimes, again, students sometimes have trouble deciding where the area that's involved here. And remember, keep reminding yourself that you're only looking at what's between the graph and the x-axis. So I see some students, filling in this triangle or this triangle here. If it's not between the graph and the x-axis, then it's not a region that we care about. So you may want to start off just by lightly shading in your region so that you're not getting distracted by other shapes that is not part of what we're dealing with. I know we see other triangles, but if it's not between the graph and the x-axis, then it's not involved in our shaded region. So triangle here, triangle here. A lot of these are symmetrical, so if we can find the area of one, then they're all going to keep repeating itself. So this right triangle here is 2 times 1/2 base times height. 1/2 2 times 4 is 4. So a lot of these will just be 4s or negative 4s. Okay. I want to combine the regions from 4 to 10. So 4 minus 4 minus 4. F prime of 7. This is the F prime graph. So F prime of 7 is just the order pair. F prime of 7 just be this point here. So that's a -2 order pair. F double prime of 7 would just be asking for the slope of the F prime at that point. So we just pick 2 points here, or pick any point on this line segment down 4 over 2. Or -2, slope of -2. Okay, on what interval between -4 and 12 is the graph both increasing and concave up at the same time? So create your slope and concavity sign line. Remind yourself that you're looking at the F prime graph. So if you want to label accordingly, you can. Above means positive slope. Below means negative slope. Peaks and valleys represents points of inflection of your F double prime sign line. And then the positive and negative slopes represents concavity. Okay, so I'm starting off with critical points, land on the x-intercepts there. So -2, 2, 6, and 10. I'm just looking to see, is my graph above or below the x-axis? Below would be negative, above would be positive. So between -4 and -2, below. Then above. 2 to 6, still above. And then the rest are below. F double prime. Now I'm looking at my peaks and valleys, which will be the points of inflection of the original graph. So 0, 2, 4, 8, 10. Okay. Now look at the slope of my F prime. Positive slope will translate to concave up. Negative slope will translate to concave down, and they're just going to keep alternating. Looking for regions increasing, so I want rising, but at the same time concave up. Only these 2 regions is going to line up, right, where it's both positive and concave up. So in other words, I'm looking for something that is above the x-axis and showing me a positive slope. So -2 to 0, and then from 2 to 4. All right, next part, find the equation of tangent lines. So plug -1 into the function to get your order pair. You may be pulling some data from the table since you're involving G prime. And then to find the slope, you're going to build the derivative. To build the derivative, what's involved here? Product and chain. Yeah, so product first, since product has a wider impact than chain. So we start with a larger rule first. And then once we're inside product rule, then we can work in the chain rule. And then we can plug -1 in and then convert function notation to numeric values and get it down to a number, and that's your slope, and then do point slope form. All right, try that. Okay, so now you're dealing with G graph, or G function. So we're no longer going to look at the graph anymore. We're going to refer to the table now. You can find your order pair first, or you can find the derivative first. Either way, we know we have to eventually get to our order pair and our slope. F prime G plus FG prime. Force square becomes 8x. Keep the G function, keep it F. G prime of U becomes G double prime of U times G prime. Then we're just replacing all the x values with -1. Pulling from our table to get G times -2 and G double prime with -2. Combine those values to get your slope. Order pair comes from the original function. You get order pair -1, -4, slope is 40, and then point slope 1. Okay, bottom of the page. Okay, we're going back to limits. Limit as we approach a real number. What's the first thing that we do if we see a limit problem? Plug in, right? Let's just see what happens, right? We plug in. If we get a real number, then we can stop. But if we don't get a real number, then we can decide what to do after that. So first thing we do is plug in. Replace every x you see with 2. Again, I'm not going to be picky about this, but just for your knowledge, if this is a free response problem on the AP exam, they may take off a point if you use equal sign. They don't like that. They call that the linkage error because these are technically not equal to each other if we evaluate. So the safer thing to do is put arrows to indicate, okay, to tell the grader that I'm just telling you what my next step is, but I'm not going to say that they're equal to each other. I'm not going to take off points, but I'm just letting you know that's one of the, the quirks of their grading a little bit. At least that, of one of the quirks that they have.
Do you have to show like all the work how you made it?
No, you don't. Yeah, I mean, if you realize that this is just going to give you a number, you don't have to show all the work. Yeah, but if you know all this is equal to 0 over 0, then you can just jump to that. Yeah. Okay, so e to the g prime of 2. We're looking at g prime of 2 here. That's -5. So that's e to the -5. E to the -5 is the same thing as 1 over e to the 5th. So that is ending up 0. And then g of 4. G of 4 is 4. So 4 minus 4 is 0. So that indicates indeterminate form. And if we see indeterminate form, what does that allow us to apply? What can we do? Remember L'Hopital's rule? Okay. So L'Hopital's rule says if we get 0 over 0, I mean, if you get a real number, then you would stop. But if you get a 0 over 0, you have the ability to evaluate the derivative of the numerator and then separately derivative of the denominator, and then replug in and see if that will get you any closer to a real number. Okay, so I'm just going to go directly into my derivative process. E to the u, derivative is e to the u times u prime, right? So e to the u becomes, or e to the g prime becomes e to the g prime times what? G double prime. What happens to 1 over e to the 5th? 0, yeah, it's a constant, so it's just 0. Okay. All right, the denominator's derivative, g of 2x becomes what? It's 2, yeah. And then the 4, careful, also drops out to 0. All right, so now we have the derivative version of the expression. Let's reevaluate. Let's see if we can get any closer to a real number. So g prime of 2, look at our table of values. G prime of 2 is -1. G prime of 2, my bad. G prime of 2 is -5. G double prime of 2 is 3. And then G prime of 4 is -2. Okay, so that is a real number, so we can stop. I'm just going to do a little bit of cleanup here. Putting that e down to the denominator, so 3 over 4.
You stop at your second class day.
Yeah, that's fine. I prefer positive exponents, so if you just drag that e down, then you can leave it like that. Just be careful that sometimes students do L'Hopital's rule directly from here to here, but you really need to show that you're getting a 0/0 before you do L'Hopital's rule, right? Let's say you got, a 5/10, then you should stop, right? Because that's a real number. If you get a 1/0, you should also stop. That's a real number. If you get a 10/0, you should also stop because then limit is undefined. You only go further if you're getting a 0/0. If you see this on the AP exam, it's most likely that they want to see that process of L'Hopital's rule, but just make sure that you're showing and that you're getting that 0/0. Sometimes they do throw a curveball and it ends up being a real number, and then you just stop. So, but just make sure you're going through that evaluation process before you decide whether you have to go any further or not. Okay, I think we've seen a problem like this before. Is there a time on the interval such that G double prime of C is equal to 2/5? Or sorry, G triple prime is equal to 2/5? So we're trying to guarantee a specific value. We don't have G triple prime in front of us, but we do have G double prime. So what is this problem trying to get us to apply here? Remember, similar problem. Yeah, mean value theorem, right? So obviously, if you have the table of values in front of you, then you would prefer to just go through IVT, where you can just pick a point above and below and see if this value actually lives there. But if you're a slope away or a derivative away from your data, then you have to rely on mean value theorem. So mean value theorem is initially, well, this is the adapted one, but we can adapt our own. And go through this process, right? We have G double primes data, so B minus A squared. Right. So we're just taking mean value theorem and just adapting it to further derivatives down. And we just see if this is true. See if we can find a slope between two endpoints on the G double prime level that's providing us 2/5. If this slope here is 2/5, then we know that there must be a point on the G triple prime graph that will also be 2/5. And so we're able to show that there is an average rate of change of 2/5 between the two endpoints at the G double prime level. So if there's an average rate of change of 2/5, there must be an instantaneous rate of change of 2/5 somewhere along the curve. All right, let's do one more and then we can stop. So part F, find K prime of 3, which we have to involve here if we want to find the derivative. Yeah, it's a nested chain rule, but essentially it is a large chain rule. There's no product rule here. So identify your outside portion, identify your inside portion, and then take turns building out your derivative. Oops, times 2. So outside derivative, G prime becomes G double prime, and we keep everything inside the same. And then we're ready for the inside derivative. F prime of U becomes F double prime of U times U prime, and then the -1 drops out. Sure.
I didn't.
Okay, thank you. Thank you.
Oh, I do.